So how might we need to be able to identify these and use them? We want to rewrite the expression using a double angle formula, and we want to verify using your calculator that they are equivalent. So when you verify in your calculator that they are equivalent, you're going to do a y1 and a y2, graph it, make sure that you've got the same graph coming up in both cases, that one overlaps the other entirely, and that is how you use your graphing calculator to show that the two are equivalent. So first we need to get to that point. What else is this equal to? Well, I look at this formula and I say, well, which double angle formula does it look like? Does it look like 2 sine of x cosine of x, right? Which would be sine of 2x. Does it look like cosine squared of x minus sine squared of x, which would be cosine of 2x? Or is there a fraction involved making it look like our tangent of 2x? Well, this is definitely the sine of 2x. However, this number needs to be a 2. So I'm going to rewrite my 4 as 2 times 2. So I've got 2 times 2 times the sine of x times the cosine of x plus 2. I have two terms. This right here, once I break that 4 up into its factors of 2 times 2, I can use just the factor that I need, which is 2, and I can say, well, this is still 2 times 2 sine of x cosine of x. Well, that's the sine of the double of this angle. So the angle is x. Doubling x gives me 2x. And then I have plus 2 at the end. See this plus 2? That's still there at the end. Now I have two terms. Both terms have a 2 in common. So I've got 2 times the sine of 2x plus 1. So that is what I would probably write down as my answer. However, I would also be prepared that they would have, they as in the textbook writers, would also have maybe that answer as a possible answer, because both are correct. One is in factored form and the other one is not. Now, if I want to verify that these are the same thing, in y1, I would put 4 sine of x cosine of x plus 2, and in y2, I would put 2 sine of 2x plus 2. When those two graphs ended up overlapping and being the same exact thing, I would know that I indeed simplified it and they are equivalent expressions, definitely equivalent expressions. We're going to try and rewrite cosine of 3x plus sine of x times cosine of 3x minus sine of 3x. Let's try and rewrite that, so go ahead and press pause. Meanwhile, I'm going to work it out. So I'm working it out here in black. I'm going to FOIL. I already recognize that these are conjugates of one another, so my outer and inner are going to cancel out. So I'm going to have cosine squared of 3x minus sine squared of 3x. This right here is my double angle for cosine. So my 3x needs to be doubled. So this is going to equal the cosine of a double angle. So when I double 3x, I get cosine of 2 times 3x, which is the cosine of 6x. So that is the cosine of 6x. So if you got cosine of 6x, you're good. You're golden. You got it. Okay, in the next example, we're going to practice making out triangles, finding the missing side, being very aware of what quadrant our angle is in, and finding the sine of a double angle, cosine of a double angle, and tangent of a double angle